Hello everybody, we are going to work on homework 3. So let's see what we have. The expected gain or loss of an experiment over the long run is called expected value. Check. Fantastic. Next one. If the first experiment can be performed in 9 distinct ways and second experiment can be performed in 11 distinct ways, the two experiments together can be performed in how many ways? Practically, we have the experiment that can be performed 9 ways, and then first experiment, and then second experiment can be performed 11 ways. Okay, and we need to find out in how many ways can be performed both experiment. When it says every time you hear both, which means and, right? And this experiment and that experiment, this every word can be replaced with the word and. Then in that case we are going to do multiplication between two events, which one is first experiment 9 distinct ways and second experiment is 11 distinct ways. So if we multiply by each other, we are going to get 99. Fantastic. Moving to next question. If 2 states are selected at random from group of 10 states, determine the number of possible outcomes if group of states are selected with replacement or without replacement. So we are going to look into 2 cases. In one case, the group of states is selected with replacement, and another way is selected without replacement. So first question is with replacement. With replacement, yes. So when we have with replacement, which means they select and put it back, right? So total amount is going to be the same, correct? It's not going to change. Therefore, since we had a group of 10 states, so you select it out of 10 states, became 9, and then you put it back, it's replaced it, and became 10 again. So we are doing 10 times, and because we have 2 states, and first group of 10 states, and second group of 10 states, which means we are going to do 10 times 10, just like previous case. Gonna be 100. Nice work. Next one, if the states are selected without replacement. Okay, one group is 10 states, so you chose one. For the other group, we have left 9, right, states. So this time we do 10 times 9, which is going to be 90 possible outcome, 90 states. Okay. Moving to next question, number 4. So experiments done without replacement will result if we don't replace. So let's say it was 10 first event, we took 2 of them, and for the second event we have left 8. So the second event depends on first event, right? Which means it's going to be dependent events. Checking. Bingo. Moving to next question. So experiment done with replacement, which means we have group of 10 states. We took out 2 states and then we put it back. Okay, so we gain the same 10 states. So, and therefore they don't depend on each other, right? Therefore, this is going to be independent group. Excellent. Moving to next one. So find the probability. Let's write down this. If P and B is 0.5, okay, okay, this is not gonna work. Let me push this down. Okay, so give me a second. I will explain obviously. 0.5. What else we have? Probability of A 0.7. And probability of B 0.6. So what do we need to find out? We need to figure out the probability A or B. Okay. So, first of all, let me explain what means probability A and B and probability A or B. Sometimes, let me bring example. When I'm saying what's the chance that both events will happen, which means and sun will shine and we will see rain at the same time. That's and, right? But if I say what's the chance that either sun will shine or we will see rain, that's gonna be or, correct? Okay. So what's the difference between and or? So the logical and, mathematically expressed as multiplication. I put star, multiplication. Logical or, it's replaced in math with addition. Okay, so let's understand this probability A or B. The formula for this, okay, let me rewrite it nicely. Probability A or B is equal probability of A. See, because we have or, we are using plus probability of B and minus the part that where they are overlapping each other. I will explain. So from here we can say that probability A or B is equal probability of A 0.7, probability of B 0.6, and minus probability A and B is 0.5. So that means 0.7 plus 0.6 is 1.3 minus 0.5, it's going to be 0.8. Okay, let's see. Zero 0.8. Fantastic. Moving to question number 7. Okay, what do we have in this case? Let's read the question so we can understand. The manager at the local auto shop has found that probability that a car brought into the shop requires an oil change is 0.66, which is 66% probability. And that the car bought into the shop requires brake repair 0.34, meaning 34% chance. And the probability that car requires both and oil the change and brakes is 0.23. Okay, for a car brought into the shop, determine the probability that the car will require and oil change will require oil change or brake repair. So and oil change or brake repair. Here we are going to use this formula again. Here it is, probability A and B. So where probability of A, it's going to be oil change, right? Probability of B, it's going to be brake change. Let me write down oil so we can understand. Is 0.66. Probability of brake was how much? 0.34? Yeah, 0.34 and 0.23. Okay, 0.34 and together oil and brake. Why I put uppercase? Because it's important. Remember the logical and we convert into multiplication mathematically. 0.23. Let's double check. Okay. So we need to find out what's the probability for either oil or brake will be done. So probability of oil or brake, it's going to be equal. So probability of oil plus probability of brake and minus probability of oil and brake. So this is equal probability of oil 0.66 plus probability of brake 0.34 minus probability of oil and brake is 0.23. So 0.66 plus 0.34. So let's start. 6 plus 4 is 10. 1 is mine. 6 and 3 is 9. And 1 is going to be 10. And it's this 1 will roll over, will be 1. Minus 0.23. Okay. I'm going slow so you can see. So borrowing from this one, 10 minus 3, it's going to be 7. So here will be left 9. 9 minus 2 is 7. And here will be 0 because I borrowed that one already. So 0.77. Let me try. Where from the 0.77? I have no idea. Now 7666. Okay. Well done. Next question. A single die is rolled one time. Find the probability of rolling a number greater than 5 or less than 2. Okay. Number greater than 5 or less than 2. So our number is, let's say, write down number greater than 5 and this or number less than 2. Okay, so number greater than 5, it's gonna be only, so we're talking about dice, right? We have how many? 6, right? On this on the face of the die. So 1, 2, 3, 4, 5, 6. Greater than 5, it doesn't say greater or equal. So only greater than 5, it's gonna be 6, right? And less than 2, it's gonna be 1. Correct? Let me see. Yeah, it's gonna be 1. So in this case, so probability of number greater than 5 or number less than 2 is going to be equal probability for number greater than 5 plus probability for number less than 2, recognize the formula, minus probability for number greater than 5 and probability of number less than 2. Okay, so when probability greater than 5, we have 6, but we are interested not in a value of 6, but we are interested of amount of elements, and there is only one element, 6, right? Because when you're rolling dice, you can have only one, be it 6, be it 5, when you roll the dice, right? Be it 4, it's only one outcome can be. So, which means probability of number greater than 5, it's going to be only 1 out of total 6. Next, probability of number less than 2. Let me make it clear so you can understand. If it would be probability for number greater than 4, then we would have greater than 4, it's going to be 5 and 6, 2 elements. We would have 2 out of 6. Okay, if I would have greater than 3, so then will be 4, 5, 6, will be 3 out of 6, which will be 1/2, right? Okay, since we have greater than 5, and greater than 5, it's only 6 there, so 1 out of 6. Now, less than 2, it's still, we have here only 1, correct? Less than 2, therefore it's going to be again 1 out of 6. So we are doing 1 out of 6 plus this another 1 out of 6 and minus, what's the chance that at the same time can happen greater than 5 and less than 2? 0 chance, right? So we'll do minus 0, and we're going to get 2 over 6, which is going to be, if I reduce by 2, this is 1, this is 3, and we get 1/3. And this is the answer, 1/3. But before I move the answer there, let me bring some another definition, or not definition, but explanation, so you could understand. Let's say I'm asking for number that is greater than 3 and number that is less than 4, right? Greater than 3, what we're gonna have? 4, no, let's put less than 5. We're gonna have 4, 5, and 6, right? Less than 5 is gonna be 4, 3, 2, 1, correct? Now, probability of first one is going to be 3 out of 6. We have 3 elements. Second one, it's going to be 4 out of 6, right? So 3 over 6 plus 4 over 6 and minus probability of number greater than 3 and less than 5. So when we look into that, see what's happening here. This 4 is repeating itself in both cases, so it will give us false result, correct? will duplicate 4. Therefore, how many elements are duplicating? Only one, that's a 4. Therefore, I'm doing minus 1 over 6. This is why here I have 0, because greater than 5, less than 2, they don't have overlapping. Okay? Just so you understand. All right, so the answer is 1/3. Let's enter. Okay. Nice work. Moving to question number 9. Okay, so we can figure out what's happening in there. What do we have? Suppose you draw a card from well shuffled deck of 52 cards. What is the probability drawing a 10 or a queen? Drawing 10. Okay. Drawing 10. To draw 10, how many 10s are there? 4, correct? 4 10s. So probability of 10, it's gonna be 4 out of deck is 52. Probability of queen, right? It's going to be how many queens we have? 4, correct? Also out of 52. Let me reread also. So what's the probability of drawing 10 or queen? Okay. So probability of 10 or queen. Now, do we have here any overlapping? I don't think so. 10 and queen have nothing to do with each other. Nothing to overlap. Therefore, it's going to be 4 over 52 plus 4 over 52 and minus 0, right? It's going to be 8 out of 52, right? If we reduce by 4, it's going to be 2 and it's going to be 13. So 2 over 13. And this is probability of 10 or queen. 2 over 13. Let's put this way. Very good. Moving to next question, question number 10. So, which notation expresses the number of permutations of 6 items taken 4 at a time? Okay. 6 taken 4 at a time. And the permutation. Let me explain permutation, and then obviously we're going to face also combination. When you select some events out of total outcome events, outcome or all events, we are using either permutation or combination. Let's say out of team consists of 12 members, 5 of them are going to go on Olympic Games, so with selective numbers out of total, right? So in that case we are using permutation, and we want to know how many choices we have, how many groups we can create this way. So we are using either permutation or combination. Since both of them exist, that means there has to be some difference. Permutation, where the order is important, which one you would choose first. Okay, let's say out of, I don't know, 14 candidates for United States president, we are going to vote only one, right? In some cases, order is important. In some cases, order is not important. Let's say order important. So there are some election or some, let's say, okay, we vote the elected the president, right? And then there is goes by order. President has to choose vice president, and then the cabinet of minister and so forth stuff and all this stuff. It's going by order. Combination in let's say you have a big library and you don't have space in there anymore. Let's say you want to choose some elements out of there, some books, and place on a different shelf, and you don't care, doesn't matter to you which books, you just grab some portion of it and put in there. That's where we use combination. Now it's asking how to read. Now that it says notation expresses the permutation of 6 items taken 4 at a time. So you choose 4 out of 6. So on the left side, P meaning permutation. On the left side, we're writing down total. On the right side, we're writing down the selected item. So this is going to be our answer. This one. Excellent. So moving to next one. Factorial. 9 factorial. Let me explain this. What means factorial? Let's say if I have factorial of 4, exclamation sign means factorial. That means starting from 4 and all the way to 1, I have to multiply by each other. Now we have factorial 9. That means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now don't ask me to multiply all this. Let's see if we need to multiply. Well, we can use calculator, no? Okay, let me use a calculator. So it's going to be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And I'm not multiplying by 1. 207,360. 207,360. Incorrect. Well, something I multiplied wrong. Let me go one more time. So 9 times 8, 7, 6, 5, 4, 3, 2. 362,880. Okay. This time I got different number. We'll see. 362,880. Good job. Question number 11. This one is very important, factorial. So factorial of 0, always 1. Always factorial of 0 is 1. Bingo. Moving to question number 13. Evaluate the expression permutation of 2 out of 5. Okay, permutation of 2 out of 5. Let me write down formula for permutation. So formula for permutation, R out of n. R is the amount that we select out of total, that is n. That's going to be n factorial over n minus r factorial. So let's solve it. It's going to be, my n is 5, right? And r is 2. 5 factorial over 5 minus 2 factorial. Okay, 5 factorial. So here I will have 3 factorial, here I will have 5 factorial. Since I have here 3 factorials, so I can put 5 times 4 times 3 times 2 times 1, right? But since I have 3 factorial, I can open all the way till, oops, that's what I wanted, 5 times 4, and then when it's come to 3, I just stop there, put 3 factorials. Okay, I can do that. Why? Because I will cancel 3 and 3. If I would have it at the bottom factorial 2, I will do 5 times 4 times 3 times 2 factorial. Okay, so end result is 5 times 4, 20. All right, okie dokie. Let's see, 20. Let's move to answer. Next question. A distinct group of objects without regards to their arrangement. To their arrangement meaning to their order. Remember I explained is a combination now. Okay. Nice work. Next question. Okay, we need to evaluate combination and permutation. Let me write down formula for combination. Combination 3 out of 7. I want to clean this so I can place formula of combination below formula of permutation so you can see the difference. Combination R out of n, again it's going to be combination of n, factorial of n, and then r factorial times n minus r factorial. So the only thing I added here is r factorial. Okay, so let's back and solve it. What do we have? Combination 3 out of 7, and then same thing for permutation. Combination 3 out of 7, obviously r is 3 and n is 7, right? So it's equal 7 factorial and then 3 factorial times 7 minus 3 factorial, and we have 7 factorial, 3 factorial times 4 factorial. So between 3 and 4, 4 factorial is higher, and I'm going to work with 7 open till 4. 7 times 6 times 5 times 4 factorial. So therefore 4 factorial stays same, but 3 I'm going to open 3 times 2 times 1. Okay, this 4 factorial is gone. 3 and 6 I am going to reduce. Here will be 2, 6 divided by 3. And then this, I'm canceling this, let me see, this 2 with this 2 here, okay? And what do I have here? 7 times 5, 35. So the answer for this one is 35. Bingo. Next, we are going to do same thing for permutation. So permutation, 3 out of 7. It's going to be the same thing, 7 factorial. Instead of, we don't have 3 factorial, it's going to be only 7 minus 3 factorial, right? So it's going to be 7 factorial over 4 factorial. So it's going to be 4 times 6 times 5 times 4 factorial. Now, don't get me wrong, I can open all the way till 1, the 7, and then 4 open all the way to 1, and then cancel all 4 numbers, so, but makes no sense. So 7 times 6, 42, 42 times 5, it's 10, 20, 21, 210. As you can see, permutation gives you bigger, but number, meaning more more groups you can create based on permutation. 210. Let me write down. When they create big difference between combination and permutation. Where from that U popped up there? Okay, well done. Moving to next well done. So find the mean, median, and mode. So what number do we have? 12, 12, 13, 14. Let me write down. 12, 12, 13, 14. 16, 16, 16, 17, 28. 16, 16, 16, 17, 28. So we need to find mean, median, mode. For mean, what we're gonna do? Add all these numbers, 12 plus 12 plus 13 plus 14 plus 16 plus 16 plus 16 plus 17 plus 28. And we divide how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9. Really? Well, that's weird, not 10. Let me count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, indeed. Okay. So, dividing by 9, obviously. Let's do it. I'm going to use a calculator to fly fast. 12 plus 13 plus 14 plus 16 times 3. It's going to be 48 plus 17 and plus 28. Okay, this is going to be equal 132, and dividing by 9, we are getting 14.67 rounding. So we need to round. It's going to be, it doesn't tell us round or not. Let's see. Point. Let me double check one more time. I don't like it. It doesn't say round till when. That's mean they expect to get the whole number. So 12. Okay, twice. There are twice. So 24 plus 13 plus 14. And then plus 48, 16 times 3. Plus 17 and plus 28. Oh, I got 144 this time, no wondering. So divided by 9, this calculator, it sometimes keep numbers in memory and doesn't give me right answer. 16. Okay, so I was right to check. 16. Good job. So next we have to find out median. Let me explain. For median, you have to arrange in ascending order. Let me write down. Oh, it is arranged in ascending order. But in this case, how are we gonna work with this one? I don't want to clean it, but let me move it down. Median is about value of the middle position, center position. If we have 9, so if I come from here, 1, 2, 3, 4, from here also 1, 2, 3, 4. How did I know 4? Because 9 divided by 2, it's gonna be 4.5. So 4, the whole number 4, and that half is creating this 16. This one, middle position, and that will be my median. Okay, so 16. We get median equal to mean. That means we have bell-shaped with the bell-shaped data. And the mode. Mode is the identified by the most frequent number. It has the highest frequency. Which number has highest frequency? 16. Yet again. Bingo. Okay. We still have a mid-range to identify. So how we are going to figure out the mid-range? We are going to take upper level, which in this case it's going to be how much? 28. Let's go there. Upper level meaning max plus minimum and divided by 2. How much is my max? 28 and 12 minimum. 28 plus 12, that's going to be 40, divided by 2, it's going to be 20. Fantastic. So moving to the last question. So what is the mean? It's the same thing, mean, median, and mode. So you can do it, right? It's the same thing repeating. So for mean, we are going to add, so I'm adding all numbers, 8 plus 10 plus 12 plus 14 plus 16 plus 18 and plus 20 and plus 22. 120. How many elements we have? 1, 2, 3, 4, 5, 6, 7, 8. 120 divided by 8, it's going to be 15. So mean is going to be 15. If you want to go again step by step, you can go back and just see how I did step by step. Nice work. Now median, right? Median, since we have in ascending order, nice element, 9 elements, 9 divided by 2, 4. So 4, 8, 10, 12, 14, 4 elements. So 16 is going to be, hold on, 1, 2, 3, 4, 5, 6, 8. Okay, when we have total 8, I'm going to, it's an even number, right? So then in that case, I'm going to take middle two positions, which is going to be 14 and 16. Look, free from the left end, 8, 10, 12, and free from the right end, 22, 20, and 18, right? We have left 14, 16 in the middle. So we're going to take the average between 14 and 16. So I'm going to do 14 plus 16 divided by 2. It's going to be 20, 30 divided by 2. It's going to be 15. Yes? What is incorrect? Oh, where from this U is sneaking in? Every time U, T, some letter sneaking in. Okay. Mode. Do we have here mode? No number is repeating, so we have no mode here. Well done, and I am done. Mid-range. Okay, so mid-range, minimum is 8, maximum is 22, right? It's going to be 30, and we divide by 2, it's going to be 15. Well done. And now I indeed finished. Okie dokie.